Okay, here we have a function 1 over square root of t, and we'll be using the definition of derivative to find its derivative, and then we'll also be finding the domain of the function and also the domain of its derivative. So the domain of this function is the following. Notice that we have the t inside of the square root, so that means the inside here is just the t, it has to be greater than or equal to 0. However, because this is on the bottom, so we cannot have the 0 anymore. So the domain is just t greater than 0, and let's write it as 0 to infinity. So that's all. Next, it's a definition time, right? So g prime of t, this right here equals the limit as h approaching 0. Use this notation, we get g of t plus h minus g of t, and then all divided by h. So let's go ahead and plug in and then do the work. The limit as h approaching 0, g of t plus h, we will have to put the t plus h into here, so we get 1 over square root of t plus h. And then the minus, and then g of t is just the original, 1 over square root of t, and then all divided by h. So we have a what? A complex fraction. Because we have a small fraction, another smaller fraction inside of a big one. Let's take care of that first. And to do so, let's multiply the top and bottom by this and that. So that's square root of t and also square root of t plus h. And of course, let's also put them down right here as well. So this becomes the limit as h approaching 0. Take this, multiply by that, we'll just get this back, right? So we have square root of t, and then it will be a minus. This times that, this and that will cancel. So it just gets square root of t plus h. And on the bottom, you guys know it, don't multiply things out. Let me just keep them as how they are. So h square root of t times square root of t plus h. So that's all good. And then let's just go ahead. Because we have a square root case, let's multiply the top and bottom by the conjugate now. So multiply this by square root of t plus square root of t plus h. And then let's also do the same thing here. Okay, continue. This is, again, let's write down the limit as h approaching 0. Take this, multiply with that. This thing squared, which is just a t. And then minus this times that is actually, let's keep it the color like this. It's just the inside, right? So just t plus h, but distribute the negative. So we have t and then minus h, okay? And then the rest, h square root of t, square root of t plus h, and also square root of t plus square root of t plus h. So here, t minus t cancel, that's good. And you know what? We have an h here and also an h here, cancel them as well. On the top we have a negative 1. And now we know we can put a 0 into the h's. So here we have negative 1 on the top, over, here we have the square root of t. This right here is multiplying with square root of, it's just a dot to emphasize it's multiplying, t plus 0, and then multiply by square root of t plus square root of t plus h, which is 0. So finally, what exactly do we get? Well, this is square root of t and this is square root of t, right? So together, this is just a t. Square root of t times square root of t is just a t. And then this right here is square root of t plus square root of t, so it's 2 square root of t. And we're just multiplying them like that. So finally, you can just leave the answer like this. You can write it as negative 1 over 2 at the front, maybe, t square root of t. This is a perfectly okay answer. And just leave it like that. Alright, and now, for the domain of this thing, in fact, we have the same thing, right? T inside of the square root, so that means t has to be greater than or equal to 0, but we also have the t on the bottom, so we cannot have the 0 anymore. So the domain is also 0 to infinity. That's it.